How you doing, Year 10s? Welcome to another video. These videos are on Unit 2, what are the bonding models. Make sure you've got pen, pencil, highlighter, highlight all the highlighting, copy down all the annotations, make sure that you've logged on to EduCanon and answered all the questions. Now let's get into these videos. Unit 2, what are the bonding models? And we look at metallic bonding in this video. Understandings and outcomes. You need to be able to draw and label a 2D model of metallic bonding, and you must include the name and charge on the cation. You must also label the delocalized electrons on the diagram, and then we need to explain electroconductivity, malleability, and luster. Okay, metallic bonding consists of metal ions that are joined together in a infinite regular lattice, meaning it just continues. You can think of a regular lattice to be a brick pattern, where each metal atom donates its outer shell or its valence electrons to a sea of delocalized electrons. The metal ions become positively charged cations, and the sea of electrons are negatively charged. The attraction holding these two things together is the electrostatic attraction between the positively charged cations and the negative delocalized electrons. And that's a key point that you must be able to remember. Electrostatic attraction between ions and the electrons. There's a number of diagrams here that basically show the metallic bonding just in different ways. The first one, we have our metal cations in that infinite lattice, that brick pattern, and then between the ions we have our sea of delocalized electrons. The electrons are not contained in one area, they belong to the lattice as a whole. The middle diagram, again, we have our metal ions in a lattice, and then our delocalized electrons are the ones that are whizzing around in between all of the atoms. In this diagram, we have also shown what we call the localized electrons, which are the electrons that were in the inner shells of the metal ions. So they still belong to those ions. They're not free to move around. And then finally, on the right-hand side, we have a bit of a combination of both. Again, we've got our metal ions, our positively charged metal ions in the lattice, and then we have like a cloud of delocalized electrons. The attraction between the positive ions and the negative ions holds this lattice strongly together. Metals are generally solids, so we know that there must be a strong attraction between the ions and the electrons. You will be asked to draw and label a diagram of the metallic bonding model. So here we're going to draw a diagram of calcium. So here I have my calcium ions arranged up in that lattice formation, like brickwork. Now I need to label my ions, so I label them according to their symbol from the periodic table, and then their charge. So we have Ca2+, and I've just drawn a few here. Everywhere in between those calcium ions will be the delocalized electrons. So I have to label my calcium ions, and then I include my delocalized electrons and just show that they are everywhere between those ions, and that the ions are not connected to any one of the delocalized electrons, but they're connected to all of them. We also need to use the model to explain a few of the properties of metals. So why do metals conduct electricity, why are they malleable, and why are they lustrous? So a conductor of electricity, why is a metal a conductor of electricity? If you remember back to the prac that we did on conductivity, you'll remember that I said that to be a conductor you must contain free moving charged particles. So metals must contain free moving charged particles, and it is the delocalized electrons that are the free moving charged particles in a metal. They're malleable because the layers of ions, if they're hit with enough force, can slide over one another. When they slide over each other, they're still attracted to the delocalized electrons, so they can hold their shape. Metals are lustrous or shiny because the light reflects off the delocalized electrons. Thanks for watching Year 10s. Don't forget, drop a like on the video, subscribe if you're new, and I'll see you next time.